We're going to close up Chapter 8 with some closing questions. So, confidence. Confidence interval, confidence level. I want you to read through these one more time, but confidence interval most times at this point, most people are pretty good at this because they've written it a lot, right? We're blank percent confident that the interval from blank to blank captures the parameter and context, the true mean clotting time, the true proportion of Minnesotans who buy a Super Bowl ticket regardless of cost. So that's pretty good. Let's talk level, because this one is less commonly talked about. This really gets at the methodology used. It means, okay, I built my interval for my proportion of Minnesota residents, and I send 10 more people out to do it. And those 10 people ask their own Minnesota residents from the same, they ask 860 different people. They build their own interval. 90%, 9 out of 10 of them, or I guess 95 in the case of that problem, will come back with an interval that captures the true proportion. So we may all have different intervals, and that's why when you read multiple choice questions off the AP exam, the minute a set interval is given, you know that we're not talking about level, because level recognizes that different samples will yield different intervals, but we have a certain confidence level that we're going to capture the proportion. So if it's 90%, we say, yeah, we all have different intervals, but 9 out of 10 capture the proportion. Okay? Make sure you look back over those definitions. Formulas. You are given the formula sheet on the AP exam, and you will be on my exam as well. So use it. You have a confidence interval as a statistic. So for a proportion, that is a p-hat. For a sample mean, that's an x bar. You have a stat. And then, plus or minus a critical value. Remember, for p, that is still a z star, because we have that one little last check, NP, n times 1 minus p, that ensures we can use t, or a z, excuse me. And for x bar, we're using a t. Now, oftentimes it doesn't matter because you're just going to use your calculator, but just wanted to point that out. And then it has standard deviation of statistic, and those are given right down here. So for a proportion, it is p, 1 minus p, all over n. And for a sample mean, it's deviation over the square root of n. Now, how does sample size affect the interval? I'm going to just use some kind of shorthand here. If the sample size goes up, then the width of my interval decreases. And this really comes down to the fact that a higher sample size yields more accuracy. So I will know a smaller margin of error where that mean or proportion is. Confidence level. If the confidence level goes up, then the width increases. And the reason simply is, before, if we said we were 90% confident, that means we're saying we're covering 90% of the sample means. If that increases to 99, we have to widen our interval to cover 99 or 9 more percent of sample means or proportions. So it goes up. And finally, what do we always have to assume in order for our interval to be valid? We have to assume we had good data, that it was collected well through a simple random sample. So when you build the interval for proportions, of course, I filled in the state and conclude, because those statements are really like fill in the blank type statements. Your plan, yes, we want a simple random sample. We want our sample size to be less than or equal to 1/10 the population size. And remember that NP, and you should say, what's it equal to? And then, is it larger than 10? And that's important. Make sure you say what that actual calculation is. Don't just assume it's bigger than 10. The AP exam will expect to see that calculation. And then the do is really, you go to your one proportion, z interval on the calculator in that stat tests menu, and you report what it gives you. Now, T-statistic. Why do we even need the T-statistic? Well, it really comes down to the fact that a T-statistic allows us a little bit more area in the tails of the distribution because we're using samples versus the population. It's unrealistic to have data about an entire population. So it really is just a recognition of that. So how do you use the chart? Well, mainly what we're going to use the chart for is the bottom here, these confidence levels. There are other uses to it. We're going to revisit this chart in a coming chapter, but I just wanted to point out you on the bottom have these confidence levels. On the side you have degrees of freedom. Remember, this is a sample size, the sample size minus 1, the degrees of freedom. And so if you said, well, I want, I have a sample of 15, so degrees of freedom 14, and I can scroll over to the confidence level I want, if you were going to build by hand. There are other uses to this and other ways to use it, and we will revisit that in the coming chapter. But for now, it really was just, okay, confidence level and scroll up to the correct row for degrees of freedom. Okay, so building an interval for means. I filled in the state and conclude. You should read those, but those are kind of fill-in-the-blank statements. The plan. Simple random sample. Sample size less than or equal to 1/10 the population size. And remember, this one's a little bit different. Condition 2, we begin by, is the sample size bigger than 30? If so, move on. Okay? If it's not, then we need to do a little more work. We need to know something about the parent population, meaning if we had a sample size of 20, but they said, you know what, this comes from a normally distributed parent population, we can move on. We can say, okay, so if the original the whole population is normally distributed, we can get away with Z. If we don't know that, then we move on to a check of our sample for outliers and skew. Okay, and sometimes we're given that. Sometimes we have to make that. Sometimes they give us 20 pieces of data and we've got to make a modified box plot. And I'm going to make a little thing because that's what I would make, the modified box plot. Okay. But we may have to do some more work if our sample size isn't large enough. Once we know the sample size, or once we've gotten through and we're going to do, of course this is just a T interval. So the biggest thing here is really that condition 2. Sample size big enough, we're good to go. If not, we need to know a little more information or maybe even build our own graph. Finally, solving for the sample size. How do we solve for the sample size? Please remember, this is, a margin of error right here. And regardless of whether it's a sample mean or a sample proportion, how we solve for a margin of error is we take our Z star, always Z star, so it comes from the bottom here. And remember, we talked in the last video about why we use Z rather than T. It's because T is a function of degrees of freedom, and we need the sample size for that. This is just too many things to not know at once. And then we multiply that by our, standard deviation. We set that equal to the margin of error it gives us. So, like in the previous video, it said of 1. Now, I want to just introduce a new term here. I'm going to make a little arrow here. So that's what we put there, depending what we're solving for, if it was a mean or a proportion. We typically call this box, instead of always having to say standard deviation of statistic, we typically call this box the standard error. Okay, so this right here, we typically call the standard error, or SE. All right, so look back over videos if you've forgotten how to actually set that algebra up. But this is the big idea, that we set up that margin of error formula, critical value times standard error, set it equal to the margin of error we want, kind of fill in the blanks, and solve for n.